Okay, when you look at this one, we want our answer in grams of lithium sulfate. So we write the proper formula, grab our periodic chart, and find the molar mass. That's the first step. Then we start 109 grams per mole. We want 2 moles per liter. So one of our groups did not have this hooked together for the right conversion factor. I know 1 liter is 1,000 mils, and I have 50 mils. So calculator says 10.99456, but we can't keep all those sig figs because we only had 3 significant figures in our molarity, 2.00, so I report 11.0 grams, 3 sig figs. Now, we've been talking about mixing up these solutions by weighing out material. And if I need to weigh out 11 grams of material, I can do that fairly easily. And if I do that on a 4-place balance, I get 6 significant figures with 11.0000 grams. But sometimes we want really small amounts of solute, and so we have to make a more concentrated solution and actually dilute it. So we can calculate the concentration that is prepared by dilution rather than being prepared by weighing something out. And we say the original concentration, C1, times the volume of that original solution, V1, is equal to my new concentration, C2, times my new volume, C2. So my C1 is my original concentration, and I can use any concentration units I want. It could be percent, it could be molarity, it could be that weird grams per 100 mils that we looked at where we didn't multiply by 100. My V1 is my original volume, C2 is my new concentration, and V2 is my new volume. So we just have a relationship with 4 variables. If I know any of the 3, then I can rearrange and find the missing variable. So here's a typical question. How much 12 molar hydrochloric acid would be needed to make 2 liters of 0.5 molar HCl? Well, if you want some 0.5 molar HCl, why would you use 12 molar hydrochloric acid instead of using hydrogen chloride? Why would this be a practical thing to do? Do you know? What is HCl in nature? Hydrogen chloride? It's a gas. Okay, so it's much easier to take a solution where someone has already purged that gas through the water to make the 12 molar solution and work with that than trying to measure out a gas in the lab. Okay? So we do this for convenience. So how much 12 molar? Well, my original concentration is 12 molar. My original volume, that's what I don't know. How much of that 12 molar would I use? And what's my new concentration? I want it to be 0.50 molar. And my new volume, I want 2 liters. So we know C1V1 equals C2V2. And you can go ahead and just write this out, putting all the numbers in here and then rearranging. How many of you like to do it that way because you were raised with a calculator? Nobody likes to do it that way. Yeah, I know you don't like to do these anyway, but we'll see what works best for you. I like to rearrange first. So I want V1, so C1 times V1. I want this by itself, so I have to rearrange and divide both sides by C1. So V1 is C2V2 over C1. So now I'm going to plug these in. My new concentration, 0.50 molar, times my new volume, 2 liters, divided by my original concentration, 12 molar. So I need 0.083 liters, which is 83 milliliters. Now, I like to rearrange because this is how I was raised. I was raised and learned to do this without a calculator. So by rearranging first and just writing the numbers in the order that I'm going to divide them in, sometimes I could see if there was like 200 here and 100 here, I could just say, oh, well, that's 2. And so it was easier to do math in your head and easier to do long division. But how many of you just feel more comfortable doing this? Writing down C1, 12 molar, times V1 is equal to C2, 0.50 molar, times V2. How many of you just like to write this and then grab your calculator, multiply this, and divide by 12? About half of you. And the rest of you aren't voting. Do you have no preference? Or you like the top one? So whichever works for you is what you should do. Okay, there's multiple ways to do it. Okay, let's look at this one. What is the concentration of a sodium hydroxide solution prepared by diluting 25 mils of 0.125 molar sodium hydroxide to 500 mils? This one is phrased a little bit differently. And what I have found is that the problems my students have with these, generally the biggest mistake is they read the problem wrong and get the wrong pairs together. So when I pull them out, C1, V1, C2, V2, the key word is of, because the word of connects the 25 milliliters and the 0.125 molar. Now, it doesn't matter which one is C1 and which one is C2. It just matters that the pairs are right together. So my concentration, 0.125 molar. My volume, 25 milliliters. Those two go together. My new concentration is the unknown, and my new volume is 500 milliliters. So we know C1 V1 equals C2 V2. So we can start out writing the numbers in. 0.125 molar times 25 milliliters is equal to C2 times 500 milliliters. Now, sometimes students will ask me, because we're multiplying molarity times milliliters, do I have to write this as moles per 1,000 mils? And the answer is no, because these milliliters will cancel each other. Okay? I'm canceling the volumes, and I then cancel out the concentrations. So when we rearrange this, we get 0.125 molar times 25.00 milliliters divided by 500 milliliters, and that's equal to my new concentration, 0.00625 molar. Keep 3 sig figs. Okay, let's have you go ahead and try the next one and just do this one at your seats.